Hey guys, welcome to Coronavirus Earth Science Day 7. Now, just so that everyone knows, today is going to be basically a 2-day lesson, all right? So Day 7 is going to count for Monday and Tuesday of this week, all right? We're going to basically be wrapping up this relative dating stuff, all right? So, moving on. So I wanted to first start out by looking at this quick little do now. I know there's no questions, but I figured I'd ask them to you anyway. What would you say was the last thing that happened out of this entire picture here? All right, now in order to be the last thing that happened, it probably has to cut through everything. Now, if you said this intrusion, I'd say that you're right. Now, could it also be this? Yes. And could it also be this? Yes. All right, as we move forward, you're going to see that sometimes there is a little gray area where it could be a couple different answers. So as long as your mentality is right and your justification is right, then there is the possibility of there being more than one right answer. Okay? So here's your homework for the week. All right, this is for the entire week. These are the 2 things that I will be grading at the end of this week. Now, there were definitely a couple people that didn't do stuff. All right, and you got big donuts, big zeros in the book. So listen, I'm not trying to overwhelm you here. I think I've been pretty nice. Make sure that you're getting your stuff done. All right? All right, so here we go. A little practice. Remember, when we say something is the oldest, that means that it happened first. And if something is the youngest, then it happened last. So in this example, the first one, what is the thing that happened first? And if you said shale, you would be correct. As far as what happened last, it would be the thing that's on the very top, right? And that is siltstone. All right, next, the thing that happened first would be all the way at the very bottom. That's your sandstone. And the youngest at the very top, which is your shale. Now, in the last one, the thing that happened first would be at the very bottom, the limestone. And the thing that happened last here, this is a little bit different, would be the intrusion. Because if you look, it has that contact metamorphism through all of the layers. Now, if it's burning all of the layers, then that means all of the layers had to have been there first, right? You're not going to cut through a sandwich if the sandwich wasn't made already, okay? All right, so moving on. Practice questions, right? Little old Regents questions. Which geologic event happened first? Okay, so if you go through your choices, folding, how can you fold layers that were not there yet? So that's not your answer. Formation of rock layer 4. 4 is the bottom. That's definitely got a chance. Formation of rock layer 1. 1 is at the top. I don't know how I feel about that. I'd go with the no. Faulting along line AB. AB cut through all of the layers. That means that all the layers had to have been there first. So they're saying what happened first. What was the original thing? I'm going to go with choice B, right? This layer had to have been there first. All right, a couple more Regents questions. State the evidence shown by the cross-section that supports the inference that the fault is younger than the basalt intrusion. How do you know that the fault came after that intrusion? One thing that you should notice is that the fault broke the intrusion. And that's it. That's how you know. All right, the fault cut through the intrusion. And that's how you know the intrusion was there first. Number 2, based upon the cross-section shown, list basalt, limestone, and breccia in the order in which they were formed. So what was formed first? So we're looking at basalt, so the intrusion, breccia, and limestone. So if you look, the basalt, the intrusion, cut through the limestone and the breccia, right? So if that's the case, then we know the basalt came last. And then if you just look at the order, right, the law of superposition, limestone had to come first because it's on the bottom, and then breccia came after because it's on top of it. Okay, this is what we're gonna get to. All right, last, let's do these, knock them out of the way. Identify one piece of evidence in the cross-section shown that indicates that the igneous intrusion A is older than the sandstone layer. Older. That means that the sandstone layer is younger, that it came after the intrusion. Now, my reasoning would be, looking right here, is the intrusion burning the sandstone? Do you see any contact metamorphism between the intrusion and the sandstone? No. All right, so that's one reasoning that you would say. And then the second reasoning you would say would be that the sandstone is on top. Okay, so you could either say the sand is on top, and then you could say that there's no contact metamorphism between them. Okay. Number 7, describe the type of depositional environment in which fossilized organisms shown lived. You know that they are sedimentary rocks and they are all aquatic. So it must be some sort of marine wet environment. Okay, so going to the work that we have for today. Of course, this isn't working right now. Here we go. So here, once it loads a second, there we go. Don't forget your rules. So in this sheet, I gave you an outline of all of the rules that we said in the very beginning when I introduced this topic. So original horizontality is stating that everything must start out horizontal first, and then things happen to them, and then they can fold, and then they can tilt, and then they can fault, right? Other things can happen to them, but they always start out horizontal first. All right, superposition, oldest is on the bottom, youngest is on the top. Intrusions, if they cut through everything, then that means they happened last. They are younger, right? They will have the contact metamorphism on all sides. That's a big one, okay? Igneous extrusions. So these are the ones that came burned through onto the surface, then they cooled, and then they may have layers on top. These are only going to have the contact metamorphism on the bottom and on the sides, but not on top. And then you have faults. Okay, they're going to break the layers, and they are going to be older, right? Those layers are going to be older than the fault. The layers had to be there in order for the fault to break through them. So the fault is always younger. So these are your cross-cutting rules. Cross-cutters, okay? These are all going to be younger than the layers that they cut through. Okay, so if something cuts through something or burns through something, then the event is younger. Okay, that's big. In order to cut or burn through layers, those layers had to have been there first. Things that occur first are older, and things that come after are younger. Okay, make sure that you understand the way that the words work. All right, so I'm going to work through, I don't know, probably the first 6 puzzles with you, and then I'm going to ask that you guys finish the rest of them. All right, there's 11 examples altogether, and of which number 8 is one that I don't want you to do. I was going through it. It's a bad drawing, so skip it. All right, so number 1. The first thing that happened is deposition of A, then deposition of B, then deposition of C, then deposition of D. And for this one, that was easy. That was all the rule of superposition, right? Oldest is on the bottom, youngest is on top. Number 2, same thing, right? A, B, C, D. But then an event happened. They got folded, okay? So again, the law of superposition is something that you had to know, right? Superposition. And then you also had to remember the original horizontality rule, right? They always start out horizontal and then something happens to them. So you had to mention that something happened to them after because they are not perfectly horizontal. Then for number 3, you have deposition of A, B, C, D. Then they were folded. And then something else happened. You had intrusion E. All right, and I know the intrusion came at the very end because this intrusion burned through all of the layers, and I see that it has that contact metamorphism on all sides. So for this one, you had to know superposition, you had to know original horizontality, and you had to know your cross-cutting rule. Okay? So as we go through, they might get a little bit more difficult. I'm going to do 3 more with you. Number 4, you had A, then you had B, then you had C. Now take a pause. Is this an intrusion or is this an extrusion? You should have said this is an extrusion. And the reasoning is that there is not contact metamorphism on top. It is not burning D. And if it's not burning D, then D was not there when this happened. So you will have extrusion E, and then you will have D. Okay? So you're going to have to really be careful with the intrusions and extrusions. For number 5, you had A, B, C, D. And they're still horizontal. Nothing got folded or anything. The only thing that happened here is that something broke them. And that is your fault. Okay? Number 6. This is the last one I'm going to do with you. And I'm just going to give you, well, let's go through it first. So we have deposition of A, B, C, D. And then what happened to those 4 layers? They got faulted. And then they had an intrusion of E. Now, I know, or let's talk about it. How do you know the intrusion, how do you know this came after the fault? All right. Did the fault break this intrusion? No. So if the intrusion burned through the fault, then the fault had to be there first. So that's how you know the intrusion came after. Now look at 6 versus 7. It's going to be a little bit different. So I'm going to let you guys finish 7, 9, 10, and 11 on your own. And then you are going to go right to that sequence of events lab. Remember, this is a 2-day lesson, so I'll go right to it right now. It's right here, okay? Vocab is on you. You guys can handle that. Here's your key, which tells you what all of these layers are. Notice granite and basalt. These are going to be your lava and magma. So this is going to be like your intrusions and extrusions, okay? So it's going to be the same exact thing that we just did. You're going to write down what happened and put them in order, okay? Now, remember what I said. Sometimes things can happen out of order. So I think what I'm going to do is I am going to pick one of these and do it with you, and then let you guys do the rest. I'm going to do cross-section 4. That's the hardest, okay? And then from here, I'll sign off and give you guys your 2 days to get the work done. Remember, this is being graded on Saturday. So the first thing that I think happened is going to be B, which is deposition of limestone. It's on the bottom, right? Then E, which is going to be conglomerate. And if you are wondering how I know what these rocks are, remember what I just said? There's a key right here, and it's the same key that's in your reference tables. Okay, next, C, sandstone. Now, at this point, are those perfectly horizontal? No, something happened to them. So I usually put a star for the events, and I'm going to say that they were folded. All right, next. So layer G here is an intrusion, right? I know that because it's got that contact metamorphism on all sides. G had to have come after those layers. Okay, so I'm just going to write it in now. Okay, so I'm going to say star, and I'm going to say intrusion G. Okay, next, and this is important, I want you guys to notice this. Look at that. Looks like the tops of those folds are missing. And if you remember correctly, that's a big one. That is known as an unconformity. All right, a buried erosional surface, and that is due to weathering and erosion. Okay, then we have deposition of F, which is shale. Then we have deposition of A, which is limestone. Then, if you look, we have G. I'm going to use a different color for this one. You have G, not G, sorry, H, that burns up through. Now, is H, notice I know that H came after G because H burned through this original intrusion that we mentioned before. Is H an intrusion or an extrusion? You should have said extrusion because the contact metamorphism is only on the bottom of it. It is not burning what is above. So that means H burned through, came out onto the surface, cooled, and then D came on top. So I'm going to write event extrusion H, and then we have deposition of D, which is conglomerate. Now, Obviously, I know that weathering and erosion is happening up here, but that is not an unconformity because it is not a buried surface. All right, so this is done. That's what you're going to be doing for those other 3 sections. Okay, so you got your questions, you got to fill in these puzzles, and you got your vocab. All right, so you got your stuff for the next 2 days. Good luck. Please make sure that you do what you are supposed to do. And just remember, this is 2 days and the lab will be graded. All right, have a good one. Be safe.